In this video, we'll be talking about angular kinematics. So let's not waste any time. Boop! So I first wrote out the linear kinematic functions. So as you could tell, all these linear kinematic functions are right here, the main four ones. But as you can tell, there's, or maybe if you've watched my angular introduction to angular motion video, theta, as in radians, corresponds to displacement, x here. Omega, radians per second, or angular velocity, corresponds to velocity. And alpha, or angular acceleration, corresponds to linear acceleration. So what we can actually do is just replace all these variables inside of these kinematic equations like so. So all I did here was just rewrite x in your linear kinematics into radians and replace velocity with angular velocity. So using all these formulas, you can solve for any rotational problem or rotational kinematics problem, in which we'll be doing that right now. Just like any kinematics problem, you need to write down everything that you know. So we know that the wheel has a constant angular acceleration of 5 radians per second. So alpha is equal to 5 radians per second squared. Starting from rest, therefore, the initial angular velocity is just equal to 0 radians per second. And we know that the angular displacement is simply 300 radians. Now what we're trying to find is the angular velocity. So take a look at all the formulas and take a guess which formula we need to use to find the final angular velocity. Wait, there's some dust on my mic. Hold up. Sorry. Maybe you'll hear a noise. Wait, that's hair. That's not dust. Oh my goodness. Wow. Okay. Well, okay. Well, now that since I was talking about dust and hair, hopefully you've picked a formula by now. But the formula that you should be using is this one. So what we're trying to find is final angular velocity, and the result of this formula is final angular velocity. We have initial angular velocity, we have angular acceleration, and we also have angular displacement. So this formula is perfect. So let's set up that formula right now. And now that we've set up this formula, all we have to do is square root both sides to isolate your final angular velocity. And once you've taken the square root of each side of this equation, you'll find that your final angular velocity will equal 54.78 radians per second, which is it's quite fast. This wheel is rotating quite fast. Okay, how about for part B? Well, this was just part A. How about for part B? Well, for part B, you need to find how much time elapses while it turns to 300 radians. So you're trying to look for t now. So t is the big question mark in this case. Pick a kinematic equation and decide now. Okay, now that you've decided, I'm going to spoil it for you guys. So the kinematic equation that you want to use is actually this one. So this one, I almost underlined this one. This one will work. This one will work, but it'll just make it a little more complicated. Instead, you could just use this one, which is way more simple to set up. So if we were to set it up, it would look like so. So once you set this up, your final angular velocity was 54.78, your initial 0, and you have a constant acceleration. So you can solve for t by just simply isolating t. So once you've isolated t, the answer for t becomes 10.96 seconds. So in total, our final answers for part A is 54.78 radians per second as the final angular velocity, and 10.96 seconds elapse after the wheel turns 300 radians. Boop. So for this next problem, we have an angular velocity of a rotating rigid body, and it increases from 500 revolutions per minute to 120. Unit conversion. Nice. Okay. So we have an initial angular velocity of 500 revolutions per minute. But here's the thing about angular velocity. It can be represented by the unit revolutions per minute, just like how velocity can be represented by kilometers per hour. But we're going to turn this into radians per second for the sake of our angular kinematic formulas. I'll show you how to do that once I write down all the information we have. And the final angular velocity is equal to 1500 revolutions per minute. Okay, after in 120 seconds. So there's no more information here. So let's go and turn these revolutions per minute using unit conversion into radians per second. So what I did for the first unit conversion was cancel out the revolutions. And the reason why you can do this is because 2 pi radians is equal to 1 revolution. 1 revolution is equal to the full angular movement or the full angular rotation of some circular object. And 2 pi radians also equals a full rotation of some circular object. That's why 1 revolution is equal to 2 pi radians. Okay, let's do some unit conversion for our minutes unit. So all we did here was be able to cancel out the minutes, so we can have seconds. So we can have radians per second as our final units. Now that we've evaluated all the units, the proper units for all the information that we have, let's take a pick on which angular kinematic equation we're going to solve for the angular acceleration of the body. Equal to is our question mark. Well, for this one, we can actually pick this guy right here. So why are we picking this? Well, we have our final angular velocity, we have our initial angular velocity, and we also have time. And the only variable left inside of this equation is angular acceleration. So all we have to do is isolate angular acceleration using this formula. So let's set it up. I have set up the equation right here. And in doing a little bit of algebra, once you isolate alpha, you get a angular acceleration of 0.87 radians per second squared. So quite the slow angular acceleration, I'd say. But we've solved for part A. Let's solve for part B now. So what is part B? Well, part B asks for through what angle does it turn in this 120 seconds. So what are we trying to solve for? We're trying to solve for our change in radians. So our change in radians. Here, this is our question mark. So through what angle does this turn in 120 seconds? Take a pick. Which formula will you use? Well, if you picked this one, you're right. It's the simplest one. It doesn't even include acceleration in this because you don't even need it. You just need your initial, final angular velocities and your time. So all we need to do is set up this equation. So now that I set up the equation, all I need to do is just plug all these numbers to a calculator. We don't even need to do any algebra. It's just simply arithmetic. And once you plug everything in, you should get a displacement of 12,566.4 radians as your answer for part B. As always, I need to mention OpenStax online textbook, and I get my practice problems from there. It's great if you want to get any more practice problems or get more practice with your physics problems. Then link will be in the description for OpenStax directly towards the physics page. But as always, if you have any questions, put it down in the comment section. If this video helped, consider subscribing.